Okay, so in this chapter, chapter 3 of the lecture notes, chapter 2 of Bloomfield's textbook, we're going to continue our exploration of the laws of motion, our exploration of how objects move around, as they transit around through the universe. In the last section, we talked about kind of the basics of Newton's 3 laws of motion, dealing with how objects translate through space. But in this chapter, we're going to start making things a little bit more complicated. Most interesting objects don't just move through space very simply. Real objects spin around, they rotate around, they flip around. And in this chapter, we're going to start thinking about what the laws of motion are that govern the behavior of these more complicated types of motion. Okay, so I don't know about you, but I used to play tennis growing up, and I don't have a tennis racket here with me to demonstrate, but I was always fascinated by the following thing. If you've ever played with a tennis racket, you probably know that the way that it behaves when you spin it around and flip it around is often a little bit surprising, right? So here I have just a kind of rectangular object. It's a cutting board from my kitchen. And there's 3 fundamental ways that I can rotate this object, right? I can rotate it around any of 3 orthogonal axes. So for instance, I can rotate it about an axis that's going up and down, and that corresponds to doing this, right? Kind of rotating it like this. I can rotate it about an axis kind of pointing away from me, and that corresponds to this kind of rotation, right? Kind of doing this. And then the third way is to rotate it about an axis going this way. So that corresponds to these kind of rotations. And if you've ever played around with a tennis racket, you know that the way an object flips through the air when you try to spin it around in each of those 3 directions isn't exactly the same. So let's see if I can do this correctly. So if I spin it this way in midair, you'll notice that it spins kind of smoothly and stably in the direction that I flipped it. Same thing goes if I try to rotate it this way. I'm not very good at catching stuff, but that's good enough. But if I pick this direction, the kind of direction pointing towards the camera at the moment, you'll notice that the way that it spins in midair is much less stable. So let's see if this can work. So you'll see that in the middle of that, it kind of, it was rotating this way, but then it executed kind of a crazy spin around another axis at the same time. And I'm really trying pretty hard to get it to flip just, nice and simply. Isn't that interesting? So, I first noticed this when I was playing with tennis rackets. But once you start noticing it, you'll find that it happens with all kinds of other stuff. So, I walked around my house just a second ago. Here's a pack of playing cards, and it's the same thing. I can spin it this way, no problem. I can spin it this way, no problem. But if I spin it this way, it executes some kind of unstable flips. And I'm trying not to make it do that. Okay, so cutting boards, pack of playing cards, same thing with the spatula. If I flip it this way, it's harder to catch. But there you go, it kind of, as I flip it this way, it kind of flips and rotates along the other axis, even though I wasn't trying to push it that way. Here's the frying pan. Let's see, I can spin it this way, no problem. I guess I can rotate it this way, and that spins pretty stably. I'm obviously not a juggler. But if I try to flip it this way, you'll notice that it was kind of rotating this way, even though I was only trying to impart motion in this direction. Okay, so why do objects do that? What objects do that? Why is the behavior of rotating bodies so much more complicated than the behavior of simple translations? In this chapter, we're going to start seeing the answers to all of those questions. Actually, by the end of this chapter, where we'll also introduce 2 new conserved quantities, the conservation of both momentum and angular momentum, we will actually have enough tools to answer this question, at least at an intuitive physical understanding level, of why, when I flip funky-shaped objects around, one of the 3 axes is unstable. We'll have all of the tools we need to explain that, and we'll dive into more details of that explanation in a future chapter.